All right, so today we're going to do a entry of design data into Trimble Access on a TDC 600 controller. So on this drawing we have our vertical alignments and horizontal alignments with a longitudinal profile of this thing. The first thing that we need to do is to look at our general notes, because this is where we're going to have a few different aspects as well. Read through the notes and have a look at any relevant information. In this case, the only relevant information we have is our cut slopes and our full slopes on the side of the road. Okay, let's look at cross-section 3, access road 3. And you'll see this is a longitudinal cross-section of the proposed road with the natural ground level and the design road level. We need to gather some information from this. So we'll have our changes, we'll have our ground levels, and then also you'll see we have our center line levels, our left-hand center line, right-hand center line. So this is the only information we have with regards to the template or the profile of our road. So we'll have to use that information in our entry of our. All right, so on the controller, we are going to switch to our road module. And then from the main menu, we're going to say define, and we're going to choose road XML as a format. You'll see there's nothing there. We're going to create a new one, and we're going to give our road a new name. There's no new existing roads. Our station intervals, we're going to use the same as that is displayed on the drawing, which is 10 meters. So leave our intervals at 10. Same can be done for my horizontal intervals, and our methodology is going to be relative horizontal alignment. Input method is point of interest, and then our transition type depends on the design, but for this one we'll just use the clothoid spiral. Vertical alignment, again, the type of data we have, we're going to use the start and end points for this one, and the geometry entry is the VPIs. And then click accept. Now we can quickly go and then define our road using our horizontal alignment first. Click on horizontal alignment. You'll see there's no records here, so we have to define our horizontal alignment. First of all, go to add, and we are going to start our start point. What is our start station? It's going to be 0. What is the method? We are going to key in our coordinates. If you have surveyed coordinates already in there, you can select a point from an existing file. But for our case, we're just going to use. Now, currently you will see that the northing and easting is displayed here, but if we look at our data, we will see that our coordinates is actually displayed in our grid format as a Y and an X. Now to change that is pretty simple. Let's just go back for now. We go to our job and we're gonna go to the properties, and then in our units section, we can scroll down to our coordinate order, and then from there select your YX coordinate order. Accept. Open that one, And we are back in our horizontal alignment, and we can now just go back and say add station 0, and now we can key in our coordinates. So starting with our start points Y, I'm just going to enter this data by copying, pasting. I'll copy that one and paste it in there, and then copy the X coordinate. In a field, you'll obviously use the keyboard just to type it in if you have it on a paper format. So this is our start station, and we say store, and we have our first point selected. Now it will immediately go to our next point, so it asks for the next point of intersection Y. So we will go along and continue with point of intersection 1's coordinate, copy those, and copy those. All right, but now if we look at our data, you'll see at our point of intersection, we already have a radius assigned to a curve. So now we need to define that curve type, and there's a few options, but because we've got a radius, we are going to use our circular method and just enter the radius for that method. All right, the arc length will be calculated as we enter the data following up. I'm just going to quickly run through this data, and we'll get back when we've entered all the data. So once all the data is entered, it will take us to the last page, which shows the next interval. We can just say close, and then it will show us in a list all of our data. If we scroll through this list and we select, we'll also see that our arc length is now calculated for us by the program. At this point, we can say accept, and that is basically our horizontal alignment done. We can now continue and do our vertical alignment. Same thing, we're going to add our vertical alignment just as we've done with our horizontal, but our type of information that we're going to enter is different. So if we look at our drawing, we can say there is our peg distances or changes, and we have elevation. And this is what we're going to use to enter here. So at station 0, we're going to enter station 0, and our elevation is going to be the 1 to 9, like that, and put that in there. Paste 1 to 8.55. Now slope in, slope out is not calculated, but we will get that as we go along. So store, and we're going to do the same for the next point. We're not doing circular arcs, we're only doing points as we've done with the previous one. Deck, and we're going to pick 9.7. We're going to take that one, and we're going to paste it in this position, and then the elevation, copy and paste it there, and enter. And now you will see our slope is now calculated between the first point and the second point. Third point, we're going to enter our drainage and paste and copy. paste, enter, and our slope is now calculated. And you'll see those correspond with what the design was done by the engineer. All right, at this point we can store and close this vertical alignment. So now we've done our horizontal and our vertical alignments. Now the only thing left to do is do our. So if we look at our drawing, look at the information that we have available. As previously stated, we only have a basic template for this piece of road that gives us our center line with a left offset of 1.5 and a right offset of 1.5. And then the difference between our heights of the center line and the left hand side is positive 0.04. So we can just do that, enter this data into our offset. It's basically two offsets that we will have. All right, so back in Trimble Access, we're going to open templates and we're going to create new templates. So I'm going to add one. So let's do the left hand side first. So call it left. There is no current road, or we're going to use it for the current road. There is no other road selected, and there are no other templates available either. So we can say add, and it will switch to our cross-sectional view with this little crosshair as our center of our road. From the center, we're going to enter a new string, and the string is going to be to the edge of the road. And then we're going to see that the method that we're going to use, you have a few different methods, but depending on the type of data that you have available, in our case, just the offsets, horizontal and vertical, we're going to remain on using or switch to our delta elevation and offset methodology. Side slopes are normally for our embankments, and we'll get to that later. So delta elevation. So on the left hand side, we had a delta elevation of 0.04. So we enter 0.04 and enter, and you will see that it displays as up. If it was down, we can switch it here to down. Okay. Our horizontal offset is going to be 1.5 meters. Enter, and we're not going to apply super elevations or widenings or anything on this one. Click store, and there we have our first line string for our road, from the center of the road to the edge of the road. All right. So in general, this is the basic information we have available, but we also want to add the embankment type. So if we switch back to our drawing, we have entered this data, and there is no other profile data anywhere, except if you remember in our notes, we did find the cut and full slopes for our embankments that needs to be entered into this profile. So you'll see the cut slope is 1.5 and the full slope is 2. So now from this end, we're going to put our embankments in. So we're going to say new entity here. String name, we can call this bank. And now we're going to use the side slope method. The side slope will generally take from our current position with the GPS to where the predicted side slope is going to be to our current position on the natural ground surface of as measured by the GPS. So side slope, and now it asks for our cut slopes and our full slopes. However, you'll see if we look at the units, it is currently set at percentage, but the drawing gave it to us as a ratio. It's a 1 to 1.5. So we have to go and change that in the program to a rise and run, which is a 1 to 1.5. And then if we go to the full slope, same thing. We're going to change the units to ratio 1 to 2 and enter. You will see that the cut slopes or the slopes will change to a percentage afterwards, but it wouldn't matter in our case. You'll see it still calculates everything correctly. If you have a cut ditch width, you want to add a ditch width, you can add it there, but in our case, we're not going to do that now. And this is how it will look. So if we are in a cut situation, we will use that line, and a full situation, we will be able to see that line. All right. So at this point, we are done. We can accept our template, and this is the template for the left-hand side of the road. But now we also want to create a template for the right-hand side. So we're going to add another one. We're going to call it right-hand side or right. It's still in the current road, but now we have our left template available. And because they're not that much different, I'm just going to use that left template. However, our bank or our road is now different. Remember, if our left hand was higher than the center, but our right hand side is lower than our center. So we have to change our point there, our offset have to change from +4 to -3 in this case. So to do that, we're going to select that road entity, make sure that it is highlighted, and then go edit. We're going to change our value from 0.04 to 0.3 and make sure that it is down. Our horizontal offset still remains 1.5, and now you can see that our profile has changed to the correct. I'm going to accept that, and we are going to accept that one as well. So now we have defined our templates, but the program still need to know where these templates are positioned. So we're going to start off from the start of our profile. So from point 0, our left template is going to be left, and our right template is going to be right. And we can store that. All right, going back to the drawing, we're going to now look at our total length of our file. We can see we're looking at about 1.372, and that 5, that must be 7 there, that's wrong. So that's a 137-22, and it's also going to be the same. So from the start to the finish, we're going to use the left template for the left-hand side and a right template for the right-hand side. And then we can say store. And now our entire thing is right. Close that, and we can accept. How do we want to interpolate this? We're going to interpolate by elevation. And accept. And accept again. And that is all for now. We do not have super elevationing and widening, so we don't have to enter that. It's a very simplified road that we have entered at this point. So store this alignment, and you can see now it is listed in our RXL file. Escape, and we will now find our thing on the screen. We can zoom to extends, and then we will see our little road there at the top. All right, let's just, in our emulator, I just want to bring my rover closer to that point. And zoom extent. There we go. There we have our road that we've entered with our starting positions and all the intersection points right to the end. Okay. All right, so now to stake out this point, we are going to go to main menu. We have defined it, and now we want to stake out this road. So click on stake out. I'm just going to simulate my RTK station here. Roads, connect to the base. Okay, yada yada. And we are going to choose this road as the one that we want to stake out. Let's say next.
Initialization has been gained.
We have that, and we're going to set our antenna height and our station intervals that we can choose at this point. Say next, and now we will be able to see that the road has now been connected. It's going to ask us, there's a few options that that you will be able to stake. Best or the easiest one to use is our to the nearest string. So you will walk with your GPS close to the starting point of where you want to start. And I just want to zoom in there a little bit. Zoom, zoom. And let's go to this point. Where is it now? Start. And you'll see it doesn't give us anything. If I move my rover here, it will try and zap to the closest point that it's available here from our current rover position. And then from here, it's a matter of just walking to your position. In the bottom of the screen, or you will see our vertical distance here is far off because I'm using an emulator. I would have to just adjust that to bring it closer into proximity. This little aircon or airplane icon will bring us to a vertical or a cross-sectional view. I'm just gonna again bring my simulated height up because my rover is far 55 meters away from my genuine or my design level. Just gonna bring it up a little bit, bring it up, and from there, if I zoom extends, I will be able. So you will see that it brings us to a predicted position. So I'm going to try in my uh, horizontal position on the right hand side, bring it close to the target, and then the little blue dot here is indicating my position where I would need to or try to be. Once you're satisfied with your offsets, you're happy with your offsets, you can say store. It's going to measure, and you can use your codes for your naming convention for whatever you need it to be. Go bank right, enter, and let's measure this point. And store. And now we have our deltas as we need to be. And this is the information we want to
Observation
give to
stored.
the client. So now after restore, and so you will continue. So now as you move along this road, you will be able to move along the cross section and be able to set out each and every one of those points as you go along. Because we're using our closest point. So as I move, you'll see my next point would be that blue dot, and it will try and get me as close as possible to that point. And this is basically how we're going to do and just complete your road by setting out all of those points. Thanks for sticking with us. Have a good one. Bye.